Good. So, hi everyone. My name is Pablo. I work at the training team here at ClickHouse, basically creating content, delivering training, and helping users. So, yeah, very glad to be here. I'm originally from Brazil. I currently live in Spain, even though I'm located in Brazil right now. It's winter here, but actually quite warm for most winters around the world, which is really nice because I don't like the winter or the cold, actually. I don't mind the winter. Yeah, we just have a poll going on. So if you can let us know a little bit more about you. So what's your ClickHouse knowledge? What's your main use case for ClickHouse? And are you migrating to ClickHouse from any of the following technologies? So kind of the technologies you're currently using. And yeah, so that is great because when I'm talking, I really, it's nice if you understand a little bit better, like what are people background, what are they doing? Are they coming from a logging, observability, or just something else? I'm here today with Rich Raposa, which is the director of education, learning, training on ClickHouse. And yeah, maybe you can introduce yourself, Rich.
Yeah, thanks, Pablo. Hi, everyone. Rich Raposa. I am in South Dakota. Been at ClickHouse really since the company started almost 3 years ago now, and super excited to have this. This is our first delivery of the Postgres workshop. So very much looking forward to it. So, all right. Thanks, Pablo.
Great. Do we have the poll results or do we need to end it? Or...
I think I'll end it just to get it out of the way. We got 60% participation, which is okay, I guess. So, all right.
All right. So yeah, welcome. This training kind of came from what we see in the field, which is a lot of users like coming from PostgreSQL, and yeah, basically at some point they reach a limit within what Postgres can do, and they start looking for alternatives in terms of mainly performance, right? And ClickHouse is a obvious tool to look into because it's definitely performant and can do a lot of things. So this is the whole idea of the training. It's kind of discuss the differences between the two. Why would you migrate? When and how? And that's what we're going to go through. We really welcome questions in the chat. It's quite boring to be talking to a screen for 2 hours, so the chat is key for us to actually be able to get it more interactive. So feel free to ask any questions as we go, and I'll try to address all of them, and Rich will also help as well. So yeah, I'm gonna go through an intro, a little bit of the why, then we go into like schema design within ClickHouse, and at the end, some data modeling discussions. Important thing, this training is really focused on kind of the first step. So I definitely envision another training of another workshop where we actually go more into like the CDC, the change data capture, and how to synchronize Postgres to ClickHouse. This is kind of the first step into understanding the differences and what it takes to migrate. Good. So why move from PostgreSQL to ClickHouse? So PostgreSQL, as probably you all know, since you're joining this course on how to migrate from PostgreSQL, it's an online transaction processing database. So it focuses on transactional guarantees. It's a really good database for you to be basically doing updates, deletes, inserts, and having those transactions, being able to roll back. So on a daily use of adding things and changing and showing things to user, that's where you should go to. But there are some performance limitations. So as you start growing your Postgres data, you start reaching some limitations in terms of performance, especially for analytical queries. So analytics use cases really see a very drastic change in performance, right? And then comes ClickHouse, which is a no-line analytical processing, so a no-lab database with the main goal of efficiently querying vast data sets. So it was built for a different use case, not for the daily transactional use, but actually to get a lot of data, analyze it, and really understand it. And yes, of course, ClickHouse also has some performance limitations, and it's the opposite. It's actually when you need to do like heavy transactional workloads. All that said, I think overall ClickHouse performance is great for vast data sets. And when you migrate, especially if you're not in like this huge data set use case, you're going to be just mind blown by like all the speed and everything. So I'll touch on all of those, but I think it's really important to get people thinking about that early on. So I'll do some teasers here. And there are some huge differences between Postgres and ClickHouse. The first one is that ClickHouse is not a row-oriented database like Postgres, but a column-oriented database, which means it's optimized for analytics. And the main difference is how you write to disk and how you read from disk. So in a row-oriented database, we write the entire row. So if you want to access one of the columns, you actually need to read the row and get the column out of it. In a column-oriented database, we do the opposite. We write to disk, so we store the data in a columnar fashion. So if you want to read a row, you actually need to read from multiple parts. But if you actually just want to do analytics on a single column, we only need to read that column, and that's way more efficient. And another efficiency there is also compression. You get a lot from compression, which optimize writes and reads as well. So that's a huge difference. Okay. So questions, I'll address when I finish the slide. Yeah. So in ClickHouse, primary keys, they are not unique. And that's a huge shift. So in PostgreSQL, we have been used to like have a primary key. We have been used to have a foreign key, and the primary keys, they are unique. When you try to insert on top of a primary key, you get an error, right? And either you do like an upsert or something like this. But in ClickHouse, no, primary keys, they are not unique. Actually, they are often repeated, and I'm going to explain how primary keys work in ClickHouse. Primary key has no notion of foreign keys. So again, coming from a relational database like Postgres, you see a lot of primary keys and foreign keys and relationships. ClickHouse has no such notion. You can still have a table with an entry with an ID and another table with an entry that actually links one to another. So you can do joins. They are supported, and we actually have a lot of different algorithms so you can tune performance. But referential integrity constraints are left to you to take care of. Okay, so it's not a relational database. We don't have this notion of foreign keys, and we don't have any support in terms of features for that. Finally, materialized view, they are different from the Postgres one. And in ClickHouse, they are an insert trigger. I'll talk more about that at the end. But when a query is executed and there is an insert to a table, you can have a materialized view on that table that basically says, oh, get this insert to the table, but also execute this query and then insert into this other table. So it's a different concept than what we see in Postgres. Good. So is there going to be any coverage of how the recent PeerTV purchase by ClickHouse will change what people may have been doing in the past? Yes, absolutely. We didn't schedule this training knowing about the acquisition, but definitely it was very timely, and we'll talk about that. So at the end, we'll have 30 minutes with the PeerDB folks doing a demo and talking a little bit about how it changes the picture. I'll touch on it a little bit throughout the course as well, but that's mainly it. We are developing data warehouse in PostgreSQL and considering to move at least some parts of it into ClickHouse. It would be good if you can touch upon things to consider, especially for large tables. Yeah, absolutely. That's what we're here for. So in order to talk about all that, we need to have a data set. There is a lab as well with the course that hopefully you have time to do. Initially, I thought we could do the labs within the workshop, but with the acquisition that we had yesterday, I think it's better to have time at the end to talk about it and just give you the whole labs as homework. But yeah, we'll share the links in a bit, and let's get to know the data set a little bit more. So we got the Stack Exchange data set. I imagine all of you are familiar with Stack Overflow. It's just a forum where people ask questions. There are a lot of technical questions over there, and other folks answer those questions. And you have votes, upvotes, downvotes, you have scores, you have users, you have the posts, you have the votes. It's all public. Here's the link. You have access to the slides later as well, so you can follow it. We got the Stack Exchange data set. We simplified it a little bit, and we focus on users, posts, and votes. So they have way more things, but we had to simplify to make it like a better training. The raw data is around 40 gigabytes, and the simplified version for the labs is around 100 megabytes. So we can really just play with the training without having to wait for a long time for things to happen. It's around, I think it's actually the 2024 data set. It's about 3 months. Good. There's a reference slide at the end where you can have the link to the data sets. So let's look into the data sets. Post is what you would expect, right? You have an ID, you have the post type. Is it a question? Is it an answer? Is it a comment? You have the accepted answer ID. You have the parent ID if a question comes from another question, the creation date, the deletion date, the score, so on and so forth. You got the user. User will have an ID. You might have a reputation, when the user created the account, what is the display name, when it was last accessed, URL, location, the about me of the user. They also have the views, the upvotes, and the downvotes. It's a little bit of the analytics they keep, as they also have some analytics in the posts. The data set, we also have badges. So users, they get badges over time as they help other users. So you have the ID of the badge, the user ID, the name of the badge, the date that it was given, and some other things, like if it's a bronze, gold, or silver badge. Very timely with the Olympics here. The tag based, it's also like a Boolean basically telling you about the badge. You got the votes. So a user, the user ID votes on a post. That's the post ID. And there is also a vote type. So you have different type of votes. You can, like, for example, make it favorite, or you can just like do an upvote or a downvote. The creation date, so when did the user vote, and yeah, bounty amount, don't worry about it. And you also have like two lookup tables, like the vote types and the post types. So looking at the whole picture, you have post connecting to users, but also with the post types and the votes. You have the badges to the users, the vote types to the votes. So it's a very relational data set, and that's really important because when you are using PostgreSQL, you have a relational use case, and that's really important when we discuss how to migrate to ClickHouse. Why ClickHouse and not other OLAP solutions? That's a very good question. That's not exactly what I discuss here, but I definitely can give you a few hints. In our documentation, we actually have, where is a ClickHouse comparison? So if you go to this URL, for example, here's a comparison to BigQuery. And if you use this comparison, you could probably put in there like Redshift and some other ones as well. The whole idea of going to ClickHouse and some other OLAP solution is ClickHouse is definitely faster than most of them, actually than all of them for the analytics use case. And it's also cheaper in most use cases as well. So you're getting a faster solution, you're getting a cheaper solution, and it gives you a lot of added functionality with a lot of the functions we have. So I would say it's probably one of the most modern OLAP databases out there, and it's definitely the go-to in my opinion. If we have time at the end, I can talk a little bit more about that. Next week, we actually have another workshop that I'm going to be delivering about BigQuery and ClickHouse. So how to migrate from BigQuery to ClickHouse. And that's definitely like talking about performance and talking about cost and what you gain from not using BigQuery and using ClickHouse. Good. So that is the data set. Just to give you an idea of the size of the data set, we have about 51 million badges, 59 million posts, 22 million users, and 200 million votes. Post types and vote types are just lookup tables, very tiny, 8 and 14 entries. Just to give you an idea of like what we are working on. And yeah, we use that at the end when we talk about how to remodel things into ClickHouse. So we take the size into consideration as well. Good. Great. Please keep the questions coming. I think they're great. Let's go deeper into the main conceptual differences. So as I said, primary keys are different in ClickHouse than PostgreSQL. So in PostgreSQL, they are unique. So each record can be uniquely identified. You have referential integrity constraints. So Postgres ensures that a value in one table matches a value in another table, and it's going to give you an error if it doesn't. You have cascading actions like delete on delete cascade, on update cascade, and that makes it very easy for you to have those relations and to actually manage them as you insert data, update data, delete data, and it automatically propagates the changes. ClickHouse, as I said, there is no uniqueness. So records are not unique and they can have the exact same values in terms of primary key. And there are a lot of good strategies for deduplication. So people usually think, oh, but if the primary key is the same, like how can I make sure I can deduplicate or I don't have duplicated entries in my database? We do have a lot of different strategies to cope with that. And it depends a lot on the use case. ClickHouse doesn't have referential integrity constraints, as I said, so no concept of foreign keys, no cascading actions, so it doesn't propagate changes. That's entirely to the user to take care of. Okay? Partitioning, that's also very different. So in Postgres, it's usually a technique used to basically divide a large table into smaller pieces. And you usually do that because you want to improve performance, right, over large data sets. In this case, each partition is going to be a subset of the main table. It's going to be stored and managed separately, okay? So in our data set, if you think the votes table would be with, I think it's like 200 million, right, entries. Yeah, this 2V here is wrong, sorry. It should be 200 million. It would be like a great candidate. The key part here is that within Postgres, we go to partitioning as a way to gain performance. The way data is stored without partition is limiting you in terms of scalability, right? That's not true in ClickHouse. In ClickHouse, we have no need to create explicit partitions in most cases. Why? Because the way data is stored in ClickHouse, ClickHouse already has internally this idea of splitting table into parts, which are not ClickHouse partitions. It's just the way we do it internally. So you don't need to extra split the table to gain performance, right? So you're going to use partitions in ClickHouse when you actually need to gain manageability within the data you have. So let's say you want to age data after a month and you want delete data after 2 months. Then maybe having partitions over month is a good idea because it makes it easier and more performant to actually delete and age the data. Okay, but it's not to get this day-to-day performance that you usually use partitions for in PostgreSQL. Yeah, so really important to be used with care within ClickHouse. They will create parts that can be merged outside of the partitioning, and that's limiting ClickHouse to do its own thing. I'll talk a little bit more about that later on. And there are specific use cases, but to be honest, if you're getting started with ClickHouse, don't worry about partitions. Just use ClickHouse straight forward and move on with that. How to achieve cascading effect in ClickHouse? Are there any built-in functions? No, you don't have any cascading effects in terms of delete on cascade, delete on update, and there are no built-in functions. Right now, you would need to do it all manually on your own with external scripts. If it's in terms of materialized views, we'll talk about that later on. And then, yes, you could use an insert to actually do multiple inserts within ClickHouse, but that's like more of a OLAP strategy thing than a strategy that you already use in Postgres. Any questions so far before I talk about indexes? Let me stop here, sorry, for a second and just take questions. Yeah, here, my bad. So would you define more primary keys instead of partitions? Yeah, I absolutely would focus on primary keys over partitions. And I'm going to talk about that in a bit. I think it's probably the next big topic that we go through. No, it's actually later in the workshop. But yeah, we definitely focus on primary keys. Anyone else? Yes, no? Okay. Indexes. So in PostgreSQL, there are like special data structures that you kind of create to speed things up. Primary keys have this default B-tree index, and they are mainly used to locate specific rows. So when you want to speed up locating rows, that's when you create indexes within Postgres. They improve the speed of data retrieval operations. They added additional storage space and slower write operations. They are often used to optimize query performance, especially for large tables, right? In ClickHouse, they are slightly different. So ClickHouse doesn't have this notion of an index like Postgres. We don't have like a B tree where we locate rows. What we actually do is a sparse primary index. That's the default index from the primary key. And instead of being used to locate a specific row, it's actually used to skip a large number of rows. So it's also used for performance reasons, but in the sense that we are usually pruning rows out of the result set instead of locating rows that should be included to the result set. Also, instead of having like a specific index, we actually use a sparse primary index, which is a different way of building the index, and it's optimized for exactly skipping large number of rows. By default, it's built off the primary key, which how we sort the data in disk, and primary keys are really, really important in ClickHouse, and we're going to talk about that. Yeah, we'll make the recording available within the course. We're going to share a link soon. And yeah. So data skipping indexes, if you heard about it, they are not the same as indexes in PostgreSQL. They might look like, they might help you improve performance in ClickHouse, but they are specific to some use cases. We don't touch on it in this specific workshop, but if we go to our free on-demand courses, we do have some modules that talk about it. Great. So how do you access PostgreSQL from ClickHouse? So I'm going to be using ClickHouse Cloud throughout this training instead of just my open source ClickHouse. Here I have a few services, and one of them is already running. It's in the Mumbai region, and I'm going to talk more about why that in a bit. If you want to create a new service, you can just go here and choose from AWS, GCP, or Azure. You can choose a specific region. If you want to do the labs for this course, what I did, so you can go through the labs in this course, is I created a Postgres instance that's running. I actually think I have it right here. Yeah, it timed out. It's going to come back in a bit, my terminal, and then I can show you. So I have this PostgreSQL database running in the Mumbai region of AWS. And I added this data set into it, and I made it only available to the Mumbai region in the cloud. So you need to create a service in our cloud, which you can have a free trial and not pay anything for it. I suggest you use the development one. Just give it a name like Postgres training demo, and I can create my service. It's going to take a few minutes to create the service. You can limit IPs and stuff. I don't need it right now. I don't need my password as well. I'm going to be using only the UI. It's going to start provisioning. Meanwhile, I also have other services. So like this one. And from here, I can access Postgres directly. So the Postgres is running on this IP. That's the public IP. That's the name of the database that I have, Stack Exchange. That's the name of my table, badges. That's the user. That's my password. So from ClickHouse, either cloud or my OSS ClickHouse, it doesn't really matter. I can do a select and I can access Postgres directly, right? So if I run this query, we are using the reduced data set, as I told you. So we have about 3 million badges in the Postgres database. Let me see if the Postgres database is back. No, my terminal is not coming back to me. It will in a bit. I can do more. I can actually do a describe table, and I can see how this table looks like. So I can see there's an ID, there is a user ID, a name, a date, a class, a tag based. I can see the types. So these types, they are not Postgres types. They are actually ClickHouse types. So when I ask ClickHouse to connect to Postgres and describe the table to me, it connects to Postgres, it looks into the data types, it transforms those types into Postgres types, and then it do the computations, or basically just show it to me in this case. We can do a little bit more of a query. So now I want to see the name and the count of the badges. I want to group by name. And the nice thing you can do in ClickHouse, you can do like an order by, and instead of having here like account, name, and put here like account name, I can just reference saying like, okay, it's the second select that I have. That's what I want to use as an order by. So if I run this query, oh, no, I don't want this. Sorry, there was a semicolon in there by mistake. It's going to come back to me with like popular question, notable question, nice answer, yearling. So those are the different badges that you have, and those are the most popular badges that people get. Let me check the chat. All good so far. Again, ClickHouse is from the cloud connecting to my Postgres instance. Yeah, it's back. Which is completely separate instance, complete separate service, complete separate thing. Let me go sudo PostgreSQL. Yeah. So for example, if I want to do select count from badges. Oh, sorry. C Stack Exchange. Oops. Let me make bigger. So it's exactly the same result, exactly the same thing. So I'm connecting from the cloud to Postgres. ClickHouse is getting the data and it's running the query. There are some optimizations that can go in. So depending on the query that you're running, it actually runs the query in Postgres and then gets the results. Some others, it actually gets all the data and runs the query in ClickHouse. Would you use ClickHouse types instead of Postgres types? When and how? So in this example, so ClickHouse can actually manipulate the data. It needs to like kind of cast the types. So you have the specific types in here. I'm going to talk about types as well when we have like the equivalent types within ClickHouse. But yeah, I'll just table the discussion for a little bit later. So where does the grouping and ordering take place? First of all, ideally, you're not going to be doing this like all the time. At some point, you want to migrate the data to here or just query Postgres directly. I think the group by and the ordering in this case actually happens within ClickHouse, not Postgres. But it's just a way to access, right? Like that's not what you're going to be doing and how you're going to be querying stuff in production. Another way is to actually create the table within ClickHouse and point that table to Postgres. So instead of writing this long IP, database, table, user, and password, I can do it once. But in this case, I need to actually define the table. And from now on, I can just run a query like select count from Postgres badges. And it's going to be doing exactly the same thing it was doing before, but now with a shorter way of writing it, right? I can do the same describe, I can do the same select, and it's just going to work out of the box. Yeah, you can definitely see it's actually bringing all the rows into ClickHouse and doing the query in here.
So Maze
You can do an
kind of a funny question, Pablo. Like, why put the data in ClickHouse if it only takes 1.2 seconds to query it, you know?
No, absolutely. So again, I don't want to run a query here that used to take 60 seconds in Postgres, and now it's going to take 20 seconds in ClickHouse because we are all going to be staring at the screen for this long time. So that's why I created this small reduced data set of just 100 megabytes, which is going to be fast no matter what. So we can just play with it. To be honest, I don't think I need to be convincing you that ClickHouse is fast. ClickHouse is fast. It's way faster. And if you just take it for a spin, you're going to see it. And me just running and having you believe and me just saying, I think are pretty much the same thing. So yeah, this is a small data set as just to show you things that you can do. It's definitely going to be faster in a real one. I'm not sure if we do have Postgres here like this. Yeah, we do. So if you just go through this page later on, you can read more about like real use cases and how they got like queries 1,000 times faster with 50% less disk space, 5 times cost savings, right? I think my job here is actually to go through it and show you how to do it. Another way, you could do it with a different database, sorry, with a different table. So here I'm just going to a different table. Now it's the post table. I could create the table and just do everything the same way. So different ways of accessing. Finally, another way of accessing that does not work in the cloud is actually using database. So you create a database within ClickHouse, and that database is basically pointing to a Postgres database, not a table. And it doesn't work in the cloud, so I cannot show it to you, but you would have access to the database and you could access the tables within the database, and that just makes it easier for you to, like a query like stack exchange dot badges. So those are just different ways of accessing. The slides cover exactly what I just showed you. This is like a high level picture of the PostgreSQL function accessing like directly a table, a database with a table engine accessing directly a table, and the database engine accessing the database within Postgres. Good. So if you want to migrate things, what you're probably going to do is either use this or this, migrate the data, and be done with it. We would break for a lab one. Lab one is basically exploring PostgreSQL data from ClickHouse. Let me get the link to the labs. Is this one. So, yeah, no, sorry. I want this here, and I want this there. So this is the course. If you come to this page, if you don't already have a login to our learning portal, I recommend you create one. It's free. Our courses are free. We actually have a lot of different courses in there. So if you just enroll to the course, you at some point end up in a page like this where you have the slides and the labs. So if you start the course, oh, that's slow. You can start the course. Those are the slides that are just covered. As an example, you have some of the links in here as the references. And then you can just go to lab one and then just follow through. I don't think we'll have time to do the labs, as I said before, because we're giving extra time to the PureDB acquisition discussion at the end. So what I'm going to do is I'm going to go through some of the things. So yeah, remember I created this service, like the Postgres training demo. Again, it needs to be in the Mumbai region. That's the only region from that can have access, and it needs to be within AWS. And from here, from this newly created service, I could just start running queries to play with the data set, better understand what the data set looks like, and just go through it. So that would be lab one. I'll leave it as a homework, and let me show you a little bit of the docs. So I showed you how to access Postgres from ClickHouse, right? And I said things like database engines, table engines, etc. So a database in ClickHouse, when you create a database, that database will have an engine associated with it. And by default, not by default, like what we usually use is the atomic. If you can have the replicated one. In the cloud, we actually have a shared one. And one of the options is the PostgreSQL. So that's the one that I showed that doesn't work in our cloud as a database. For table engines, we actually have a lot of them. So if you look at integrations, if you're just not interested in Postgres, you could look into RabbitMQ or Kafka or just the Azure Blob Storage. But if you come to PostgreSQL, you see all the details about it in here. And finally, if you go into table functions, you can see the functions that you can use to access an external storage directly, just like I showed you. So PostgreSQL is going to be here in the list. And by using it, you can just directly go to access Postgres, if you have the permission, of course. Yeah, it does download it, the whole Postgres table, and then run the query within ClickHouse. There's some small optimizations, but it's very like use case specific. Yeah, exactly what Reach said. So if there are some filters, it's going to push those filters to to Postgres, and then get all the data and run within ClickHouse. Great. Any more questions before we go into the schema design? Good. So, if I understand correctly, we had two options: query Postgres tables from ClickHouse or bring data to ClickHouse and play with it. How does it change performance cost? Yes and no. So throughout the course, I'm going to show you how to bring data from Postgres to ClickHouse. At first, let's say you're getting started with the migration, right? So you just want to play with it. You want to see how ClickHouse performs. You want to check some types. You want to think about it a little bit. So an easy way of actually accessing all this data without having to ingest all the data or do many things is to just start a ClickHouse instance and from ClickHouse access this data. You have three different ways of accessing it. One is just using a function, always passing the URL, the table, the database, etc. Another one is to actually create a table so it encapsulates all this meta information, and then you can directly access the table. And the other one is just creating a database, and then you have full access to the Postgres database. I would say that that's usually how you start playing with it. You start like looking into the data, checking things out. But if you already know your data, you probably don't need to do all this discovery, right? So we basically just go into the next part. In terms of performance and cost, definitely going to Postgres on every request, copying all the data and running the query in ClickHouse is far away from being optimal, right? Especially in a production system. So it might make sense in a few cases, but more often than not, you're actually going to at some point migrate all the data to Postgres, and then you're just going to run you're going to migrate all the data to ClickHouse, and then you're going to either query Postgres when you need transactional stuff or query ClickHouse when you need analytics. Does that make sense, Mason? Sorry, no, it's Alireza. So again, if you're running a query from ClickHouse to Postgres, the query is going to be executed within ClickHouse. Okay? Only a few filters are going to be pushed into Postgres to optimize what comes. Let's say I have a where filter that I only want to get data with a specific ID. It doesn't make any sense to move everything to ClickHouse and then filter the ID. So this type of filter will happen in Postgres, and we are only going to get the rest of the data. But everything else, like any more complex query, it's going to be executed on the ClickHouse side.